So let's just go back to here. So basically, in order to finish procedure call, basically we have the caller, right? There is the procedure called the other procedure, which is called callee, which is that procedure called by the caller. And then I need to do is the caller need to call the callee, but before that they need to prepare their argument, which potentially can be used by callee. And the argument you need to find somehow to pass this argument into the callee, right? And then the callee will implement this procedure in it, and then will return the value back to the caller. So in other words, before they transferred, after the callee finish those procedure, those implementation, and before they return the control back to the caller, then you prepare the return value. Somehow this caller has to be able to get that the return value. And then the control transfer back. Basically, it's a call. Basically, the main procedure will be prepare argument and the call callee. Callee will request the memory for the implementation and implement, and then prepare the return value and then return the control or transfer the control back to the caller. So now, in order to understand the detail of the procedure, let's see what kind of instruction we use to realize the procedure call. So that procedure call is called the jump and the link. Okay, so through this instruction, I can finish this procedure call. Basically, caller call callee, and at the same time will transfer control to callee. So jump, this J is referred to jump. Basically, transfer the control from caller to callee with no condition. And then what means link? As I mentioned, link basically means I need to make sure after the callee finish the implementation, it can return back the control to the caller, right? So that is called the link. So for control back properly, that basically deal with some memory address. Therefore, if I say, and the current instruction by implementing this jump and link has a memory address of PC, can I ask, after the callee finished the implementation, where it should return the control to? Basically, where we can link back. Whether I will link back to PC, this original location, or to some place with the memory address other than PC. Please pause here to think about it. And then we can continue our video. So what I suggest is we will return in the location with the memory address of PC plus 4, because if I return back to PC, I will stuck in this loop. I cannot continue. Only when I jump from the caller to callee through the location with the memory address in PC, and after implement that, I return back to the location with the memory address of PC plus 4. Only in that case, I can continue to implement one after another instructions in the caller. And how I can make sure after the callee finish, I can return back properly in PC in the location with PC plus 4. That is where this link do. So basically, jump and link has a format as following. If I say this callee has a label L, so basically it's a jump and link followed by the label of the procedure I want to jump to. And what here try to do is to do two things. Jump first. Basically, it's jump from this location, which is the current jump and link instruction, to the location with the label L. After that, I also do another thing called the link. Basically, I will store the value PC plus 4 in another general purpose register, which is called the return address register. So basically, I will copy or store the location where, or the address of the location where I want to jump to into a general purpose register. This helps me to link the control back to the appropriate location. Let me say one more time. In order to realize the caller to callee, what the instruction we use is the jump and the link. I think I have here. And the format is jump on the link followed by the label of the procedure I want to jump to. And what they realize, two things: jump to the address and then link back to the main procedure. Jump to the address with label L, no problem. And link back, basically, yeah, to achieve that goal, I will link the value in PC plus 4 into the general purpose register RA, the return address register. This register is conventionally only used for the store the return value. By doing that, after I finish this, the callee, I can directly using another instruction, which called let me put here. Let me put here, jump and the return, followed by the RA. By doing that, basically, which is shown here, basically is I can lead my control back to the location with the address stored in RA. So one more time, caller to call callee, I will using jump on the link, follow the label of the callee. And then by doing the same time, I'll also store the PC plus 4, this memory address, into the register return address register. After that, after the callee finished the implementation, I will using jump and return this another instruction followed by the register RA to properly to return the address, the location properly. The location is the location with the memory address of PC platform. Okay, so here is how this explained the jump and link and jump and return. So here, just talk a little bit more about the jump and the link and the jump and the return. And first, I want you to, without the continue listen to this video, I want you to guess jump and link followed by the label L. What kind of format I can use to represent this one? Please pause here and think about it by yourself and then continue. So what I suggest is using using J format. So let's try to, before that, again, like last time we talked about branching vehicle, let's say, why we're using J format. Whether we can use in R format, I format. If we're using R format, what's the problem? The problem is the memory address associated with this label, this important information, I cannot find a proper location or segment in R format to store this information. Let me say one more time. I cannot use in R format to represent this assembly language because I cannot find a proper location to store the memory address associated with label. So R format doesn't work. How about the I format? I format is okay because I have the immediate field there, but it's only 16-bit. So in other words, it's kind of limited the range of the location from where I can jump to. So another thing is I format besides operation code and immediate field, it also has two source operands, RSRT, or called one source operand, one destination. But that location, that two segment kind of wasted, right? Because in this instruction, I only have operation code and the label. I do not have any source operands. Therefore, I format is logically is fine, but kind of waste of the limited space to represent if I want to represent jump and link by using I format. And the J format actually is perfect because the J format only has two segments. One segment is the operation code. One segment is the constant. So you can see this is the operation code is a 6-bit and the constant is 26-bit. By looking at that, you can see that means J format exactly meet the requirement of jump and link, right? I have place to store the operation code for jump and link. I have a place to store, or a much larger place compared with the I format to store the memory address associated with that label of the procedure. Okay, therefore, we can see jump and link using J format is the operation code It's 3 associated with jump and link, and the constant code. So now let's look at the jump and the return. Actually, I already provide here. The reason I provide here is because this is not that straightforward. You can see jump and return, we only have two. One is operation code, one is a source operand, right? So this one is kind of special. You probably need to remember is using R format to represent that because I don't have any constant here. So it's not appropriate to using I or J format. So the R format, basically the beginning will be the operation code always 0, and the function code is 8, corresponding jump and return. And then now I only left one source operand. So for this instruction, I will put a source operand, which is RA, the return address, which has the index 31, into the RS range segment. In other words, jump and return using R format, and I only actually using or take advantage of 3 segments. Operation code, which is 0, function code, which is 8, and the RS segment, which is store the index of return address register, which is the 31. Okay, so now let's pause. Let's stop here, and in next class we'll talk more about the procedure call and how we can really store the argument value or return value to make sure the other part can access them. Okay.